Hello students, and welcome to the 6th lesson of Unit 5 Part 2. In this lesson we are going to learn to create equivalent representations by solving for a given variable. Our essential questions are 1. What is a literal equation? And 2. Given a literal equation, how do I solve it for one of the variables? Did you know that there is a relationship between the rate of an object's speed, the time spent at that rate, and the total distance traveled? It is a literal equation known as d equals rt, or distance equals rate times time. This relationship is a literal equation because it has more than one variable. In this case, it actually has 3. D stands for distance, R stands for rate, and T stands for time. Literal equations are a special type of equation. So let's first recall the definition of an equation. An equation is a statement that two amounts are equal, and we have studied in depth one variable equations, equations that have only one variable. Now we are going to look at literal equations. A literal equation is an equation with two or more variables. This is nothing new because all of the area and volume formulas that you've previously studied, they are examples of literal equations. So when you are looking at the volume of a sphere and you are using this formula, this was a literal equation. It had more than one variable. In this case, it actually had 2. V stood for volume and R stood for radius. The goal of today's lesson is literal equations are equations that involve 2 or more variables. But sometimes it's useful to rearrange or solve the literal equation for a specific variable in order to find a solution to a given problem. So for example, your volume formula was useful when you were looking for volume. But had you been looking for the radius, we could rearrange this formula to focus on what the radius would equal if we knew the volume. So the goal of this lesson is for you to be able to rearrange an equation that has 2 or 3 variables in order to isolate a specific variable. Now, here is the key to meeting the goal today. To create an equivalent equation by solving for a given variable, remember, since a literal equation contains an equal sign, we will still use the same idea that we've used with one variable equations. We will use inverse operations to isolate the variable. So the key is, whatever operation you do to one side, do to the other, and that will keep your literal equation balanced or truly equal on both sides. There are 3 steps to solving for a given variable. Step 1 is to locate the variable you are asked to solve for in the equation. Step 2 is to identify the operations on that variable and the order in which they are applied. Create the do side of an do and undo chart. And step 3, use inverse operations to isolate the variable. In other words, create and carry out the undo side. Now, what we're going to do on this slide is we're going to refresh how we would solve a one variable equation, and we're going to look at what that would look like if it were a literal equation. Same layout, but just more than one variable. So here in this one variable equation example, this is a one-step equation. If you created a do and undo chart, it would only have one operation on each side because here is the variable we're trying to isolate, and the only operation with it on that side is add 5. And the opposite of adding 5 is to subtract 5. So if we were solving this one variable equation, we would subtract 5 from each side. Positive 5 minus 5 makes 0, so we cross that out. We get x plus 0, which is just x. And since these are both constants, we can combine them to say 10 minus 5 is 5. And that means that the value of the variable is 5. Now, a literal equation has more than one variable, so we will not get a constant as our answer. In other words, it will look very similar to this because it will still have two variables in it. Now, here's our literal equation. It says x plus y, just like this one said x plus 5, but this one just says x plus y is equal to 10, and we want to solve it for x. So let's create a do and undo chart. Our first step is to identify the variable that we're looking for, okay, x, and our second step is to find the operations that are acting on it. Well, there's only one operation on this side with the x, and that is to add y. So on our do side, we would have to add y to x if we knew what these were. To undo the equation, we'll have to do the opposite. So what's the opposite of adding y? Subtracting y. So we'll subtract y from each side. Positive y minus y makes 0, so we get x plus 0, or just x, is equal to. Now, here's where it's different from our one variable equation. Remember how these two were constants? Are both of these constants? No. Are they like terms? No, because they do not have the same variable and the same exponent. So we cannot combine these, so we'll just write them together. So we'll put negative y plus 10. And if you can get in the habit of writing the variable before the constant, that will help you when we get to Unit 6. Now, let's look at another example of a one variable equation and a matching literal equation. Our first example of a one variable equation is a two-step equation. It is a two-step equation because there are two operations acting upon our variable, which is the letter c. We have c minus 6 divided by 2 is equal to 10. We can create a do and undo chart for this equation, and it would say that we would need to subtract 6 first, since c minus 6 was grouped by this fraction bar, and then divide by 2. To undo that, we'll have to multiply each side by 2, and then add 6 to each side. So if we begin solving this, we'd say we multiply by 2, and 2 divided by 2 is 1, and 1 times anything is just self, so we have c minus 6 left, equals, since we multiply by 2 on this side, we have to multiply by 2 on this side. 10 times 2 is 20, and we can combine these because they're both constants. And then our second step would be to add 6 to each side. Negative 6 plus 6 makes 0. C plus 0 is just c, so we get c equals 26. And we can combine these because they're both constants. Now, let's look at a literal equation with the same layout and look at how we can create a do and undo chart for this situation. So we have c minus d divided by f is equal to 10. Just like we had c minus 6 divided by 2 equals 10. All I've done is replace these two constants with variables. Now, our do and undo chart is going to look very similar because the same operations exist in both. We are again trying to solve for c. The operations acting upon c are subtract d, and that would be first in our do side because they are grouped by the fraction bar, and then divide by f. To undo this, we'll multiply each side by f and then add d. So we'll multiply each side by f. F divided by f makes 1, so we have c minus d left, equals 10 times f, which is 10f. Now we just need to add d to each side like our do and undo chart tells us to do. Negative d plus d makes 0, so we get c equals. Now, on this side, these two are not like terms because they do not have the same variable, so we cannot combine them, but we can still write 10f plus d. So c is equal to 10 times f plus d. Notice, for a one variable equation, we got a constant as our answer, but for a literal equation, we got an expression as our answer. Now let's do some more practice. So we'll do 4 practice problems. So we have negative 2x plus y equals 10, and we're going to solve for y. So here's our y term. We have positive 1y. If we created a do and undo chart, the only operation acting upon y is negative 2x. What's the opposite of negative 2x? Well, the opposite is to add 2x. So we'll add 2x to each side. Negative 2x plus 2x makes 0, so we're left with positive y, or just y, equals, and now notice these are not like terms because one has a variable and one's a constant, so we'll just write them together, 2x plus 10. And notice I put the term with the variable before the constant, because remember, this will help us later. This is actually called slope-intercept form. Okay, let's look at another example. 3x plus 2y equals negative 6, and we're going to solve it for y. So here's our y term. Okay, this is actually a 2-step equation because there are 2 operations acting on the variable. First, y is being multiplied by positive 2, so it's being multiplied by 2. Then 3x is being added to it, so we're going to add 3x. Now we'll have to undo it by doing the opposite, so we'll subtract 3x from each side, and then we'll divide each side by 2. All I did was work backwards here through our do chart. So our first step is to take 3x away from each side. 3x minus 3x makes 0, so we have 0 plus 2y, or just 2y, equals, now see these two? This is a constant, this is a variable. They cannot be combined because they are not like terms. So we'll just write negative 3x minus 6. Just write them down. Now, our last step is to divide each side by 2. 2 divided by 2 makes 1. We get 1y, or just y, equals negative 3x minus 6 divided by 2. Now we're not finished because we have shared division here. Negative 3x is being divided by 2, and negative 6 is being divided by 2. So we get y equals negative 3 divided by 2, and we'll just leave it saying negative 3 over 2, negative 3 halves, x, and negative 6 divided by 2 makes negative 3. So our equation is y equals negative 3 halves x minus 3. I prefer you to leave this as a fraction versus changing it to a decimal. Unless it divides in a whole number, just leave it as a fraction and you can reduce that fraction. Okay. Let's look at another example. We have 2c minus d divided by 4 equals 3. This is actually a 3-step equation. So we're going to use a do and undo chart. And remember, when a variable does not have a constant, what number is written before it? A 1. So our do side is going to say d is being multiplied by negative 1. See how it's multiplying negative 1? Then 2c is being added to it, and it's being divided by 4. So to undo it, we'll multiply by 4, take 2c away from each side, and then divide by negative 1. So first step is to multiply each side by 4. We get 2c minus 1d equals 12. Now we're going to take 2c away from each side. 2c minus 2c makes 0, so we have negative 1d left, equals, these are not like terms, so just write them down, negative 2c plus 12, divide each side by negative 1, so we get d equals, this is shared division, negative 2c divided by negative 1 makes positive 2c, and positive 12 divided by negative 1 makes negative 12.